In this video, I'm going to talk about limits at infinity. In other words, end behavior properties. So let's take a look at this two limit statement. Limit x approaches 3f of x and x approaches infinity f of x. What's the difference between these two is this is a kind of a vertical asymptote, tells you that there is a vertical asymptote at x equal to 3 versus this is telling you that there is a horizontal asymptote at x equal to 3. So the biggest difference is you must understand which one is a vertical asymptote, which one is the horizontal asymptote. Horizontal asymptote is x approaches infinity, y value is at 3. Now, before we head into further discussion, we must know the degrees of polynomials and everything about rational function. Rational functions are fractions, and in honors pre-calculus, we learn about rational functions which are sometimes top-heavy. Top-heavy means the degree of numerator is higher than degree of denominator. Some functions are same degree. For example, here 3x squared over 2x squared, same degree, and sometimes they are bottom-heavy. So these limits are going to be a little bit easier as we clearly compare the degree of the numerator and degree of the denominator. So here, for example, 3x squared over x squared, so same degree is the same, and 3 over 1 is 3. 3x squared over 2x squared, x approaches infinity, 3 over 2 is the horizontal asymptote. So in other words, there is horizontal asymptote at 3, horizontal asymptote at 3 over 2. Now, hint is when working with limit as x approaches infinity, don't sweat the small stuff. You do not worry about the other smaller terms. You always look at the leading term. That's what the small stuff means. You don't worry about the tail. You only look at the terms of greatest magnitude in the numerator and denominator. So here are some easiest example here. X approaches infinity, x square over 5x square. Ignore 4x, ignore 6, ignore 9. You can say that this is the same degree and the answer is 1/5. Okay, so here they gave you factored part. There are two factors, and we know that if we multiply negative 3x and 2x, the leading term will be negative 6x square. Negative 6x square over 3x square. You don't worry about the other terms, and this is clearly negative 2. 4x square over x cube. Now this is a bottom heavy. We know that the bottom heavy functions always have a horizontal asymptote at x equal to 0. Here you can say that 4x square over x cube is 4 over x, and we know that 1 over x function looks like let's check it out how that 1 over x look like. If you recall, let me see if I can draw that. Okay, you remember 1 over x is something like this, and the function x approaches infinity, it is 0. Okay, so here, this is considered top heavy. 2x square over 3x. Simplify these terms, 2x over 3. Okay, what is 2x over 3? This is a 2/3 x, and this function is a line, positive slope. So x approaches infinity, where the y is going infinity. This function, 3x minus 7 square. So we know that the leading term would be 9x square. In the denominator, you are searching for the leading term, which is negative 5x square. So what is 9x squared divided by negative 5x squared is negative 9 over 5. Now, this last one is a very interesting one. Sine x over x. Sine x, you should know that the sine x is never going to be more than 1 and negative 1. So the numerator will be always between 1, negative 1, 1, negative 1, 1, negative 1, but the denominator is going to be very, very large when x goes to infinity. So this is considered as bottom heavy. And bottom heavy function, when x approaches infinity, this will be 0. Okay, so let's take a look at raised to infinity. If you recall, in honors pre-calculus also, we did that. Raised to infinity means all the functions are racing towards infinity. And we must know the dominance. We know that exponentials are always the fastest. And the bigger the base, the faster it is. So exponentials are faster than polynomials when x is going to infinity. Um, you should always remember that these inequalities. So let me explain this inequality here. Okay. So in the middle group, okay, so these are all the exponential functions. The bigger the base, the faster it is. Inverse of exponential is logs. Logs are all the slowest. I call them losers. They are the slowest functions. In the middle comes polynomial. In the middle is the polynomial. Again, the bigger the power, faster it is. 100, 50, 2, there is a 1 and then 1/3. So dot 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 means all the middle polynomials. So polynomials are in the middle, exponential are the fastest, and then you also need to know when number over infinity, that means bottom heavy, it becomes 0, and number over 0, which is infinity. So all you have to look at who is in the numerator, who is in the denominator. So we are going to take a look at some very interesting combination here. Okay, so here clearly 2x square over 3x, they both are polynomial, but the numerator is faster than the denominator. So let me try this. My mouse is not working. Numerator is smaller than denominator. X approaches negative infinity, so that means 2x over 3. But the negative infinity, which means when x goes to negative infinity, it is going to negative infinity. 4x plus 1 square over 8x square, 16x square, 16x square over 8. I'm sorry, I did not see this number. This is not 18 but 8. So 16 over 8 is 2. This answer will be 2. This is a typo. 16 over 8 is 2. Okay, so what happened if we have x to the 99, very powerful polynomial, and denominator has a combination of exponential and 3x. As I said that you always look at the leading term. So the numerator has x to the 99, denominator has e to the x, and they are both racing towards infinity. So e to the x will reach infinity first. That will consider bottom heavy, and the answer is a 0. You don't have to do any work, you just recognize who is in the top, who is on the bottom, who is reaches infinity first. Now this example is a little bit complicated because we have a exponential and exponential. They both are racing. The numerator is 4 units up, denominator is 3 units down. And this is same function, but look carefully that this limit is going towards negative infinity, this limit is going towards positive infinity. Okay, so the biggest difference between these two problem is when if it is going to infinity, 4 is not making difference, 3 is not making difference, and 2x over 2x, the answer is 1. Okay, so what happens if it goes to negative infinity? We know that limit x goes to negative infinity, 2 to the x is equal to 0 because there is a horizontal asymptote on the other end. And here in this case, 2 to the x is 0 and this 2 to the x is also 0. X approaches negative infinity. So this number becomes 0, this number also becomes 0. And 4 plus 0 and 0 minus 3 is 4. over 3. So make sure you understand this question and know the difference between positive and negative infinity. There are more practice problems of this kind on the other side. Okay, so now let's take a look at the definition of horizontal asymptote. Horizontal asymptote is x approaches positive or negative infinity, and also it's possible that there could be two horizontal asymptote and they both could be different. It is possible there are two different horizontal asymptote and they both could be different. To understand this concept, let's take a blast from the past. From honors pre-calculus, we learn absolute value function. Anytime you see the absolute value function, you must split positive x and negative x. We know that the absolute value function look like. So let's I'm trying to sketch the graph. Absolute value function is positive x when x is greater than 0, negative x when x is less than 0. So a function like this, you must split in a 2 with positive x and negative x. We learned the piecewise function in algebra 2 and pre-calculus. So let's take a look at this. 2x minus 1 over x minus 3. This x is a positive when x is greater than or equal to 0, and negative when x is less than or equal to 0. You can consider 0 at both places. So now we are going to look at the limit. Limit x approaches infinity, which means out of these two piecewise function, you have to consider the numerator. 2x minus 1 over x minus 3. You can say that they are the both same degree, so horizontal asymptote at 2. So when function approaches infinity, on the right side horizontal asymptote is at 2. When x approaches negative infinity, you have to take the second piecewise function, and you can see that this one has 2x over negative x, 2x over negative x, and that will become negative 2. So then there is a second horizontal asymptote at x equal to negative 2. In the middle, anything could happen. So that's why there are two horizontal asymptote, x equal to 2 and negative 2. Let's take a look at some more concept we learn in pre-calculus. Okay, so we know in pre-calculus we learned that square root of x square is absolute x. Square root of x square is absolute x. Square root of x square is absolute x. Okay, based on this concept, take a look at this limit. Here I'm giving you, I have already written directions, everything given here, but I'm just still going to explain. X square minus 4x plus 4 factor, x minus 2 square, and square root. So this will give you absolute x minus 2. Square root of x square is absolute x. X goes to infinity, which means this will be positive, and x minus 2 over x minus 2, answer is 1. If negative infinity, this factor become negative and the same, but the answer is negative 1. Now since these two limits are different number, we can say that when x approaches 2 does not exist because 1 and negative 1 are not the same number. Okay, so let's take a look at the special function, which is absolute x over x. This is a very popular function in AP exam, and that function is again based on absolute value definition. If we split over 2, x if x is greater than 0 and negative x if x is less than 0. X divided by x is positive 1. Function is still not defined at x equal to 0, and negative x over x is negative 1. And this is a very, very popular function in AP exam. You can take a look at page number 16. I'm going to discuss that some more about this function. And this is the limit from the left, the same example here, and there is a jump discontinuity. The function is not the whole, you can't really see that. There is a open circles, and those are the asymptotes, but you can't really this is a computer generated graph, so you don't see this. And then there is a jump discontinuity at x equal to 2. Now let's take a look at page number 16. This is page number 16 in your packet. And I'm just going to explain in more detail about absolute x over x, as this is a very popular in AP exam. One more time, if you split x over x, x is greater than 0, then it's 1, negative x over x, negative 1, and this is what the graph looks like. What happens if it is a flipped, which means limit from the left, limit from the left, limit from the right. So x approaches 0 from the left. That means you are looking at that. This is a coming from the left side. That means the negative x, and the limit is negative 1. 0 from the right, and the limit is 1. And then absolute x over x, limit does not exist. There is a jump discontinuity. If it is a flipped, same scenario, x over x, negative x is the same. The both graph look same. There is still a jump discontinuity at x equal to 0. Now, if you want to look at this concept without a graph, you can still look at that is a, if you come from the negative number, that means 0 divided by very small but the negative number, and that will give you both numbers are similar, and that's a negative number. Okay, so this is a transformation. X approaches negative 3. Absolute x plus 3 over x plus 3. Why this limit does not exist? Well, back to the definition of the limit, limit from the left and limit from the right. So if we see x approaches negative 3 from the right, that means the numerator is positive and it's a 1. Negative 3 from the left, then it's a negative, and that both are same, and the negative 1. So these are very, very popular, very easy multiple choice questions, as well as free response, where one-sided limit and there is a jump discontinuity. This is the same as the transformation of the basic function absolute x over x. You can see this is the 5 units to the right, x minus 5, limit does not exist. Another example of a square root of x square. Here you can see that clearly there is a 2 horizontal asymptote. So absolute x means positive x, negative x. I have given another few more examples here. You can say that square root of 4x square. Then you can just ignore the tails. Square root of 4x square is absolute 2x. Absolute 2x over 7x. Look carefully where the limit is going, and that is infinity. So you are going towards positive infinity and positive number. So this is positive number. Here it goes to negative infinity, so that's why you have a negative sign and the negative number. One more example, don't forget square root of 5 is a square root of 5. Positive infinity, positive number. If it is going to be negative infinity, then it's a negative number. Okay, so here another example of 3 to the x, 3 to the x, infinity, ignore 4 and 5, so that's why 1. If it is negative infinity, make this 0 and negative 4/5. Sometimes open-ended question, determine any asymptote, know that this is the left-hand behavior of the horizontal asymptote, know that this is the vertical asymptote, trying to sketch the graph, open-ended question. And now for extra practice, you should work on this homework. Answers are posted in the Canvas classroom. Thank you.